Well, hello. This video lesson is for students who are absent and missed the lesson on how to make energy chains. So I'm going to show you this very quick video clip of me going through an event. And what I need for you to do is just watch the video. You will not be able to hear any sound, and that is okay. It's a very quick video, so please watch.
Emma, would you? I don't. Okay.
Are we good? Okay. This is the teacher demo, and we're going to eventually draw an energy chain to show this demo. So it happens quick, so watch carefully. Ready? All right, so take a look. And just one other thing, like if this was slow motion. Okay, and then take a look at the paper. And that's it. Thank you.
Okay. So what we are going to do now is learn how to draw out an energy chain. An energy chain is just a visual or diagram, and the purpose is to show you what's happening to energy during an event, or what's happening to energy within a system. So the important thing about an energy chain is that it actually proves the law of conservation of energy, because it's going to allow us to trace and track where the energy came from and where the energy is going. So it's proving that energy was not created or destroyed. We will use symbols and abbreviations in energy chains. So the first symbol that you need to know is something that you're already familiar with. It is a solid arrow, which represents energy transfer, energy leaving one object and going into another. And then we'll use a dashed arrow to represent energy transformation. Now remember, convert or conversion is a synonym for transform or transformation. And that means that energy is changing from one form into another. What are the different types or forms of energy? These are all the different types or forms of energy that we could talk about and have talked about in class. One that might be new to you is EPE, elastic potential energy. The other thing I want you to know is that almost all energy chains, 99.8% of all energy chains, will always start at the sun. It will always start with the sun's energy. So in other words, the energy of the event or the energy of the system originates at the sun. Okay, so what we have here is the teacher demo. Soyson grabbing the paper off the stool as the stool falls to the ground. And this is the chain that we will make. So we're going to start at the top and be able to trace the energy down all the way to the end. So I already told you that most energy chains start with the sun's energy, and the sun always expresses light energy. So the object is put in the name of the object, which can be living or non-living, is put in the blank, and then in parentheses, we identify the type or types of energy that that object is expressing. So for right now, we're going to skip over this section of the energy chain, and we're going to start probably where your mind is starting, which is when you think about that video clip. Where do you assume or think that the energy started? And most people would say, well, I would start with you, Miss Soyson. I would start with you with your arm up and swooping down to grab the piece of paper. So that is a good place to start, and we're going to put that right here. We're not even going to focus on the person, but rather the part of the body that made the energy, that was expressing the energy, right? And remember I said that we put the name of the object in the blank line, and then next to it in parentheses, we will identify the type or types of energy that that object was expressing. So before we do the types of energy my hand or arm was expressing, let's see what my hand affected next. So what we're doing is we're going, in other words, my arm transferred energy to what? So my arm is one link in the chain, and then I'm going to the next step or sequence in the chain. And many of you are going, well, yeah, your arm, your hand touched the paper. And that's exactly what is the next item or object in the chain. So energy left my hand and went into the paper. Energy left the paper and went into the stool. Energy left the stool and went into the floor. Some of you may have said the ground, and that's fine. That's one thing that I want to add about energy chains. Energy chains are considered like a work of art. Everybody's energy chain may look a little different from another energy chain because no two energy chains are going to be exactly alike. There's some unique features. So, for example, I may say ground and another student may say floor. As long as you can back up the design of your energy chain with accurate reasoning, you're fine. Okay, so now what you need to realize is that the transfer of energy happens when two objects touch. And what we've been talking about recently is when two objects collide, right? But it doesn't always have to be a collision. But my hand had contact with the paper had contact with the stool, and the stool had contact with the floor. So now let's go back up and let's identify the types of energy that my arm was expressing. Well, first my arm started up high in the air at rest. That is correct. GPE. My arm was expressing GPE. And then my arm swooped down very quickly to grab the paper. That is major motion. The energy of motion is kinetic energy. So this is how you do an energy chain. You identify the object that is possessing the energy at that particular step or link or sequence in the chain, and then you identify the type or types of energy that that object is expressing during that event or within the system. So let's talk about the type or types of energy that the piece of paper has. The paper is expressing GPE at first, right? Because it's at rest. Then the paper moves. The fact that the paper is wrinkled is physical evidence to show you that the paper went through motion. I know that the paper is expressing GPE because it's sitting there motionless, and if I took the stool away, it would fall to the ground due to gravity. But the other thing, this is what I showed in the video. As the paper rubs and grinds and scrapes against the stool, you got it, there's friction. So there's going to be a buildup or an introduction of thermal energy at that point because the paper is scraping against the stool. There's your friction, and that friction is going to force some of the paper's kinetic energy to transform or convert into heat or thermal energy. And then some of you are going, well, wait a minute, I heard the paper scratching and scraping against the stool. You got it, and that's sound energy. So the piece of paper was expressing four different types of energy simultaneously. Then the paper caused the stool to fall. Now some of you are going, well, no, you caused the stool to fall. Yes, but I caused the stool to fall indirectly because the paper was in between us, and that was what I was grabbing. So what kind of energy was the stool expressing? The same four types, because the stool starts at a higher elevation and then falls to the ground. It starts at rest and then it's in motion. So there's your kinetic energy. If you touch the top of the stool, that is where you're going to feel a little bit of heat. And of course, sound is generated between the paper and stool as friction is created when the paper rubs against the stool. So here are the four types of energy the stool is expressing. So what about the floor? The floor is also expressing the same four types of energy. I put the types of energy underneath just because I did not have enough room on the side. So GPE, the floor is not moving at first, right? If I took away the subfloor, the tile would fall to the basement of our school building. If you took away the concrete foundation in our basement, then the tile would fall towards the core of the earth. And that is because anything on earth is affected by gravity, even when at rest. So I just justified why I am explaining that the floor was expressing GPE. But remember, when we did the bouncing balls lab, I had you during every collision, put your hand on the surface, and you said that you felt vibrations. Vibrations is evidence of kinetic energy, right? It's evidence that energy transferred out of the stool and went into the floor, causing the floor to shake. Shake and vibration is movement. Movement is kinetic energy. You hear the stool hit the floor, and anything that has a collision, we already learned from the bouncing balls lab, thermal energy is usually introduced at that point of collision due to an intense amount of friction between the two objects when they bang together. Okay, so I want to go back up here. You'll notice there's a dashed arrow, and you already know that means energy transformation. I want to explain why a dashed arrow appears in between Soysun's arm and the piece of paper, but not anywhere else. And the reason is because when you go to this step or link in the energy chain, you see that sound and thermal energy are two types of energy that are being expressed that were not present in the previous step. So what you're saying is, as my arm or hand energy transferred to the paper, some of that original energy changed form into two new types of energy. So whenever a new form of energy is introduced in a step or sequence of an energy chain, and it was not present in the step before, then you would say that it is a transformation as well as a transfer of energy. So what about the second arrow here? Every object, Soysun's hand, the paper, and the stool, have two arrows leaving each object. The branching of two arrows actually means that my energy went two different places at the same time. The energy of the paper was transferred to two different objects at the same time. And the energy of the stool, the falling stool, was transferred to two different places at the same time. The second location that the energy went for the moving hand, the moving paper, and the falling stool is air. So we're going to add air. Air is always kinetic, is expressed as kinetic energy. So to prove that to you, take your hand right now and wave it really fast in front of your face. You will feel a breeze. So anything that goes through or moves through the air is going to displace, push air aside, because energy is being transferred from that moving object into the air. Air is always in motion because gas molecules make up air. Gas molecules are always moving. If I'm jogging, my feet and heels are going to be pounding against the road. So I'm transferring energy into the road, but I'm also, as I'm running or jogging, I'm also displacing or transferring energy out into the air. And this is why you feel a breeze when you run. So we're going to add air to all of the other arrows that are left. Okay, so there you go. This is the bottom of our energy chain. And remember we said most energy chains start with the sun's energy. So the question is, what do we fill in here in between? And that is answered by us realizing, well, I know where the floor got its energy. I know where the stool got its energy. I know, or do I? Where did Soysun get the energy in the first place to raise her hand and swoop it down to grab the paper? And many students already know the answer to that. It's food. I consume food or as my fuel or source of energy. Food or fuel is known as chemical potential energy. So we have talked about this also before in class. So when you hear the term, I'm burning off my dinner from last night, you're actually converting or transforming food energy that is stored in all muscle cells of your body, and you are then burning off or transforming that food energy into motion energy. Okay, so we're going to back up a little bit and we're going to add that. So you need to realize that the energy was in me all along. It was stored as chemical potential energy. All right, it's fuel that is in the mitochondria of my cells, and I'm not going to use it until my brain tells my body I need to make movement. Movement requires energy. That energy comes from food sources, which is our fuel. When you burn that food, that is when your body is going through, we say I'm metabolizing that food, or a metabolic process. The formal name for that is respiration. You learned that last year in 7th grade with Mrs. Halfin and Mrs. Arif. So we learned that every body cell in a human contains the organelle mitochondria, and the mitochondria are nicknamed the powerhouse of the cell. Well, now you know why it's called power, because it's taking food and converting or transforming that food energy into movable energy. And that is why we only have a transformation arrow here, because the energy is staying within the same place. It's staying within the same object, but it's transforming. And that is why we have an asterisk. The star is there to remind you of a very important process called respiration that we have learned before. And the process of respiration is kind of a chemical reaction where stored food energy, or CPE, is transformed. There is our abbreviation, a dashed arrow, is transformed into movable, usable energy. And this happens in the mitochondria of all of my arm and hand muscle cells, so that my arm and hand can rise up, swoop down, and grab the paper. So that leaves us with the final question. Where do we get this food energy? Where can we find it? I can pluck a strawberry off of a strawberry bush. I can pluck a peach off of a tree. I can take a piece of corn and grind it, and I can make a taco shell, or I can make sugars from a corn plant. All of food that we eat is derived from plant material. And that should make sense, because plants use sunlight and convert or transform sunlight into food or food energy. So, all food is plant derived, which means the sunlight, the energy from the sun, specifically visible light energy, transfers throughout space and transfers through the Earth's atmosphere, and plants at that point will absorb, soak up, or take in this light energy. Remember last year you learned the organelle in all plant cells, their job is to soak up and absorb sunlight energy, and that's called the chloroplast in all plant cells. The chloroplast's job is to convert or transform, there's our important terms, convert or transform sunlight energy into food. Usually it's a very simple sugar that our body processes from plant material. And remember, the name of the process that transforms or converts light energy into food energy, that's why we have a solid or a dashed arrow. The name of that process is called photosynthesis, and it occurs in the chloroplast of plant cells. So ladies and gentlemen, this is how you make an energy chain from start to finish. The majority of all energy chains, the energy starts with the sun. And then you just track or trace where the energy is going within the system. As you track and trace where the energy is going, you're also identifying the type or types of energy that that object in the system or in the event is expressing. Okay? And that is your lesson on how to make energy chains.